Hi, Chemistry 1012. I just wanted to go over a couple of questions from Chapter 11 with you. The first one is question 11.75a. And again, this is from Chapter 11. And the question says, complete each of the following by supplying the missing product indicated by the question mark. So the question mark is going to be over here. And the question is, if we take but-2-ene, so but-2-ene, and we treat it with HBr, what's the product that we're going to get? Now, I have taken but-2-ene and I've drawn a structure of it right here. So that would be this structure right here. You see but is our prefix, so that means we have a total of 4 carbons. And then our ene, so our double bond for our alkene, begins on carbon number 2. So we have 1, 2, 3, 4. Now this compound just happens to be symmetrical, so it wouldn't matter if we wrote it, I could have numbered the carbons like this, 1, 2, 3, 4, and I would still have the same thing. Now what happens is when we subject an alkene to HBr, what's going to happen is that the 2 carbons in the double bond are going to react with the hydrogen and the bromine. Now, if you've covered Markovnikov's rule, Markovnikov's rule doesn't really apply in this question. Why? Because both carbons of the double bond, this one and this one, they both only have 1 hydrogen attached to them. So there's no differentiation between the two. And so all we're going to do is we're going to break the double bond in the product, and we're going to attach a hydrogen to one of the carbons and a bromine to the other carbon. So what I'm going to do is I'm just going to copy and paste this molecule. So I'll just copy this over and bring it over here, okay, like that, and I'll just delete this. So what I'm trying to say is that what we're going to do is we're just going to delete one of those bonds. We're going to delete the pi bond, okay? Remember, the first bond between 2 atoms is always a sigma bond. The second one is a pi. Pi bonds are weaker than sigma bonds. And so now we're going to add a hydrogen to one of those carbons. So I'll add it to this one here. And then I'm going to add a bromine to this one right here. And so you could leave the structure that way. There's nothing wrong with it. But if you want to condense it further, you could write CH3, CH2, CH, I'll put the bromine up here, and CH3. So this would be 2-bromobutane. So 2-bromobutane. All right. Now, if you did the problem and you used bond line structures or skeletal structures, there's nothing wrong with that. I can show you how you would do that. So first you would start by drawing your but-2-ene. Okay, I'm going to draw it as the trans. It doesn't matter if you draw it as the cis or the trans. And then when you treat that with HBr, what you would end up with is you would end up with 1 bromine on the second carbon. Of course, you did add a hydrogen to this carbon, but remember that hydrogen is implied in a bond line structure. Okay, there's another question I wanted to take a look at with you, and that's because this question does involve Markovnikov's rule. And so the question is, they want you to react 3-methyl-hex-2-ene, so that's this compound, so 3-methyl-hex-2-ene with hydrogen iodide. So I'm just going to write it out like this. Now, just to double check the name, you see that the prefix for the parent is hex, so that means it's got a total of 6 carbons. And then we have the double bond of the alkene starting at carbon number 2. So 1, 2, there's my double bond. 3, 4, 5, 6, looks good. And then I put the methyl group at carbon number 3. Remember, you have to memorize 8 different alkyl groups, okay? You need to know methyl, ethyl, propyl, isopropyl, and then the 4 butyl groups: butyl, tert-butyl, isobutyl, and sec-butyl. Okay, so now that we have the question written out, and again, I used bond line structures. You don't have to, but I did. What's going to happen now is we're going to add the HI, but you see there's a difference between the 2 carbons. If I highlight this carbon in red, you can see it has 1 hydrogen attached to it. And if I highlight this carbon in blue, you can see it has no hydrogens attached to it. Now, Markovnikov's rule, sometimes we phrase it like this. I'll just put Markovnikov rule is the rich, meaning rich in hydrogens, the rich get richer. So all that means is the carbon that has the hydrogen already, meaning the carbon in red, since that one has the hydrogen, it's going to take the hydrogen from the HI as well. So that means that the blue carbon is going to be left over with the iodine. So let's redraw the skeleton like this. You can see I'm leaving the double bond out. Why? Because the double bond is breaking. Now, on the carbon that was the red carbon, I am going to put another hydrogen on there, but remember that hydrogen is implied in your bond line structure, right? There's also the red hydrogen there. But remember, those two hydrogens would be implied in a bond line structure, and I'll get to that more in just a second. And now our iodine is going to go onto the carbon that was formerly the blue carbon. I'll label it like that. Okay, so that is the correct answer. There's nothing technically wrong with the way I've written it. Most organic chemists wouldn't write it that way. What we would do is we would say we have 1, 2, 3, 4, 5, 6 carbons. On the third carbon, I have my methyl group, but I'm also going to have my iodine. And that would be the final product. So if you're wondering, well, how would I name that compound? Well, we're going to number it 1, 2, 3, 4, 5, 6. Why did I start from the left? The reason I started from the left is because if I started from the right, 1, 2, 3, 4, you can see my substituents, the methyl and the iodo, would be at carbon number 4, and we want them to have the lowest possible number. So the way that I have it labeled is correct. So if we make a list of what we've got some kind of hexane because we have 6 carbons. It's an alkane. There's no alkene anymore. We've got a 3-methyl, and we also have a 3-iodo. All right, remember the prefix for iodine is iodo. Now, we're going to order these in alphabetical order, so I comes before M. And so the final name of that compound, if you just bear with me, I'm going to write it at the bottom of the screen, would be 3-iodo, 3-methyl hexane. Now remember that we always separate numbers and letters by hyphens. Okay, always numbers and letters by hyphens. And if you were to have multiple numbers, one after the other, you separate them with commas. I hope you find this helpful.